everybody, we're going to be measuring the discharge of the stream. So our first step for that is to measure the cross section. So Carly and I are going to measure the full width, and then Jemima's going to come through and measure the depth every half meter. So Carly, put it at 0. All right, and I've got 4.7 meters. All right, so then Jemima's going to come in and measure the depth at 50 centimeters.
It is 24.5.
All right, and then at a meter?
26.
Okay. Meter and a half? I can add.
Thank you. 29.
Okay. 2 meters? You okay?
Yeah. And this one is at 31.
Okay. 2.5.
This one's at 32.5.
Okay.
This one's at 30.5.
Oh, and we're doing this in centimeters because we use scientific units.
Metric system.
Right.
This one's at 29.5 centimeters.
2 more. I can read this. This one's at 32. Oh wait, 5. This one's at 36.
Good.
Okay, so now we're going to measure as part of discharge how fast the stream is moving. To do this, we have a little float, and we're going to just measure how fast or how long it takes to get from 3 meters from me to Carly. Jemima's going to time it. So, ready? On your mark, get set, go. Oh, it's coming. It's coming. And stop.
10 seconds.
Like exactly. Perfect. Awesome. All right.
Okay, so we're just going to walk through a diagram of the stream width, depth, and speed measurements that we did. So the first thing we did was we measured our stream width, and that was what Carly and I were measuring as we went across the stream from edge to edge. And then we did the stream depth at every half meter. And so that was Jemima walking across, shouting out numbers as we went across the stream to tell us how deep every half meter was. And then we did our stream velocity, which was we had the float and we sent it down 3 meters to see how long it took, and it took 10 seconds. So then we take all of these things and we do it 4 times to make sure that we can get a good average. And we'll calculate discharge. And so to calculate discharge, you take the average depth of the stream channel, then you take the average width of the stream channel, then you take your average velocity of the stream channel, and you multiply all that together, and that's how you get stream discharge.
Okay, so now we're going to measure the oxygenation and the temperature of a pool versus a ripple. So I'm at a pool right now. You can tell because it's very deep and not even in the full way, and it's already up to my knees. And this is a dissolved oxygen and temperature probe. So this little bit on the end has been calibrated and ready to go. So I'm going to just drop it in the pool, and this is going to think for a little bit. We'll pause and then we'll come back once it's done thinking, and I'll tell you what the answers are. So, ready, set. We know that this is ready to go with a good reading because it says ready right here. So 7.99 milligrams per liter is our dissolved oxygen measure, and 26.6 is our temperature in Celsius for the pool. We're in the ripple this time. We know it's a ripple because it's much shallower. You can see it's not even up to my ankle. It's louder, which is from the water falling off all the rocks. And the water is moving much faster and it's a much rockier area. So we're going to measure the dissolved oxygen and temperature again. So you just drop it in. Make sure that it doesn't come up. All right, so we are ready to go. We've got our ready signal. It's at 7.28 milligrams per liter dissolved oxygen for the ripple, and it's still 26.6 degrees Celsius.